My name is Anuj, and this is a quick overview of our work. The collection of perfectly clean speech data is difficult. It requires a lot of time investment as well as monetary investment to be able to get the resources like microphones and sound dampening foam that's used to record the data. From the Noise2Noise paper ICML 2018, we know that it's possible to denoise images without having access to a true clean reference image. And so isn't it possible for us to apply the same technique in the speech domain instead? This in turn would mean that we never have to collect perfectly clean speech samples anymore. So we asked two key questions in our work. The first is, can we train deep neural networks to denoise speech with only noisy samples? And if we can do this, what's the impact on performance? We make a simple experiment. We overlaid noises from urban sound onto the Edinburgh speech corpus to create two different types of datasets. The first is called end-to-end and stands for noise-to-noise. This dataset has noise in both the input as well as the target that the neural network is trained on. There is one caveat here. The category of noise present in the input and the category of noise present in the target are different. We'll explain more about that later. And there's noise to clean, which is just denoted by N to C. And this is a traditional deep neural network training dataset. There is noise present only in the input. We use a 20-layer DCU-net model, and we train them the exact same way, barring the datasets that we used. We compared 5 different metrics on a whole lot set of unseen speakers that the network had never seen before. Here are our findings. Please feel free to pause the video to go through them in detail. But the key takeaways are these. The first is that end-to-end outperforms N to C on all metrics in 10 of the 12 different noise categories. In only white noise, does noise to clean outperform noise to noise. And in that remaining one category that's left, noise to noise outperforms noise to clean in 4 of the 5 different metrics that we have. So to answer our questions, can we train DNNs with only noisy data? The answer is yes. The caveat though, like we said earlier, is provided that the mean of the noise is 0 and the correlation of noise between the input and the target needs to be 0. The first is something that's generally present for all types of noise. But the second requirement is the reason that we needed to make sure that the noise in the input and the target were different. If the correlation is high, the network instead will learn a mapping from one type of noise to the other, which is not something that we want. And our second question was the impact on our performance. Well, it turns out it's minimal in the case of random noise where there's no useful phase information. And it's actually beneficial when we deal with complex noises, as you can see from the table earlier, as well as graphs like these. And so to conclude, speech denoising is not reliant on clean data when we're using deep neural networks, and this encourages the collection of speech from low resource languages. Adding noise can improve performance if the noise is complex, and prevents overfitting and thereby improves our model generalization ability. When the useful phase information isn't available, it still manages to achieve nearly the same kind of performance as you would get when you train with clean data.